This project incorporates a lot of the concepts we have learned so far. We are starting to put together all our skills. We will be building a fun buzzer sound recall game. Essentially, you first have to listen to a sequence of notes as they are played. LED lights will also give a visual indication of the notes. Then, you must play the notes back in the exact order you heard them by pressing the appropriate buttons that correspond to each buzzer. If you get it right, you win, but if you get it wrong, the sequence will be played again for you to attempt again. Let's take a look at the objectives for our project. By successfully completing the project, we will have mastered the following items. We will learn how to incorporate several different electrical components in one circuit: LEDs, push-button switches, and buzzers. You will also be introduced to the concept of debouncing and how it can be handled. We will be installing and using a third-party library to handle debouncing for our circuit, so you'll become familiar with how this can be accomplished. If you are ready to begin, let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, a breadboard, 3 220 ohm resistors, 3 330 ohm resistors, 3 LEDs, preferably red, green, and yellow, but if you don't have these, you can use any other colors that you may have, 3 piezo buzzers, 3 push-button switches, and connecting wires. As you can see, it's a lot of parts, a lot of components, but we'll get it all wired up. Let's first address the concept of debouncing. Switches are mechanical components that consist of moving parts. Let's say we are measuring the voltage at a particular switch pin. When you press the switch, the signal does not immediately go from high to low. As you press down, the contact is made several times and the voltage signal goes from high to low, back to high, and so on. This process is known as debouncing, and this happens a few times before the signal actually settles down. This is measured in microseconds or milliseconds, so it may seem like a short time, but it has serious implications in electronics when we take readings. If we look at the voltage waveform and try to capture it on an oscilloscope, which is a device that we can use to inspect voltage signals and waveforms, you'll see several peaks or bumps in the transition from high to low. The switch is actually making contact, breaking, making contact again, and breaking before finally settling down. It is of course very quick and cannot be seen to the naked eye. This has implications for when we take readings in Arduino to determine the state of a switch. To adjust for this or correct it, we can do several different things. We can use components, known as capacitors, sometimes to smoothen out this disturbance, or more complex circuitry such as Schmitt triggers. We can also handle this in code from a software perspective. This is in fact what we are going to do in our project, so that we do not have to introduce any additional hardware to handle the debouncing errors that were introduced. We will use a third-party library called Bounce to help us out. We need to do this because we need to be precise in determining what button is pressed and in what sequence for the playback for our game. Let's take a look at the circuit diagram for our project. As you can see, here are the 3 piezo buzzers. We also have 3 LEDs corresponding to those piezo buzzers. For the LEDs, they each have a 220 ohm resistor from the cathode or the shorter pin to ground, here and here. And for the anodes of the LEDs, the yellow is connected to pin 10 on the Arduino, the green is connected to pin 9, and the red LED is connected to pin 8 on the Arduino. For our piezo buzzers, from the negative pin of the buzzers, they each have a 330 ohm resistor that is connected to ground. So here is one, here's the second one, and here's the third one. And from the positive pin of the piezo buzzers, They are also connected to pin 10, 9, and 8 on the Arduino. For our switches, each switch has one terminal that's grounded, and the other ends of the switch are switch 1, which corresponds to our buzzer 1 and our yellow LED, is connected to pin 7 on the Arduino. Switch 2, which corresponds to the green LED, and the second buzzer is connected to pin 6 on the Arduino. And finally, switch 3, which corresponds to buzzer 3, and our red LED is connected to pin 5 on the Arduino. So quite a lot of wiring and components in this circuit. Let's see how it all plays together. Let's go ahead and wire up our circuit. First, let's put in our piezo buzzers. Remember, for the piezo buzzers, there's a positive pin, and that you'll notice that positive symbol next to the positive pin of the buzzer. So a trick that I use when I'm connecting the piezo buzzers is just to gently put them in the circuit so that you can actually see where the pins are. Otherwise, they cover up the pins and you wouldn't want to make a mistake connecting the wrong row. So here's the first one. Second buzzer. And the third buzzer. Alright, next let's connect the corresponding LEDs. So for the buzzer on the left, we're going to use the yellow LED. The one in the middle, we're going to use the green. One on the right, we're going to use the red. Let's connect the 220 ohm resistors to our LEDs. So again, they go from the cathode to ground. Right, that's the first one. Here's the second one. All right, finally the third one. Next, we could do the 330 ohm resistors that come from the negative pin of the piezo buzzers. So I'm gonna right, and remember those also go to ground, so I'm gonna kind of jump that connection there. That's the one to the left. And as you see, I'm slightly raising the breadboard so I can see specifically where that pin is under the piezo buzzer. Alright, that's the second one, and I know resistors are crisscrossing here, but hopefully you get the idea. And finally, the third one. Try also not to make your resistors touch. Alright, so try to make that as clean as possible because you wouldn't want any interference. Right, so those are the resistors. Now we'll do the connecting wires. So from the buzzer, we're going to go to from buzzer 1, we're going to go to pin 10 on the Arduino. So I'll make that here. Alright, and that actually is coming to the LED. Let's make from the connection from pin 9 to the positive of that LED. Alright, and then we're going to go from pin 8 to the positive of the third LED. Then we have to make a jumper to the buzzer. So along the same horizontal row for the yellow LED, since that is joined, we're going to go to the positive of this buzzer, and we'll do the same for the other two. There we go. To the positive here. And then for the final buzzer, again, making sure, looking to see that they all line up to the positive. All right, that was quite a lot of wiring there. So we can go ahead and push in our buzzers now, just to make sure that they're in there securely. Now we'll connect the push button switches. So here's the first one, which corresponds to this buzzer and this LED. Here is the second one, which corresponds to the second. And here is the third buzzer. That corresponds to the switch that corresponds to the third buzzer and the red LED. Alright, so for the switch, they're all grounded. So let's connect those ground pins first. Alright, now we're just going to go from the switches, the other ends, to the respective pinouts on the Arduino. So for our switch 1, we're going to go to pin 7 on the Arduino. Alright, for switch 2, to pin 6, and then finally for switch 3, we're going to go to pin 5 on the Arduino. Okay, the very last thing we need to do is connect that ground, or make that ground connection. So I'll go ahead and do that now. So from the ground rail of the breadboard, we're going to go to ground on the Arduino. Alright, so that's it.